Hey Amir, you want to throw the football?
Yeah, I'd love to play football.
For all intents and purposes, we can use the equation negative 1 over 4x squared plus 5x to represent the football's arc. So the parabola can be modeled by this equation, negative 1 over 4x squared plus 5x. So in order to find the maximum, which is the highest point the football reaches, we have to find the derivative of the f of x function. So f prime of x would then equal negative 2 over 4x plus 5. So we can simplify the negative 2 over 4x to just negative 1 over 2x plus 5. And then once we find the derivative, which is f prime of x, we set it equal to 0. And then we solve for x. So now that we found the x value where the maximum is located, now we want to find the corresponding y value. So in order to find the corresponding y value, we want to plug the x equals 10 into the original equation. So we go f of 10 is negative 1 over 4 times 10 squared plus 5 times 10. So we eventually get that it's 25 feet. So you know the location of the parabola, of the maximum of the parabola, would be at 10, 25. And remember, don't forget your statement. So we want to write the statement at the end, or at the beginning, whichever you choose. And you can say relative extrema exist when f prime of x is equal to 0 or undefined.
Wow, that was one tough workout. I could really use something to eat right now. Oh, maybe I'll just warm myself up with a potato. Let me start off by turning on the oven. Let's do 200 degrees. Alright. It's been about 20 minutes. Let me check up on this. That's not very warm. Alright, it should be warm by now. Ew, that's not warm. Now, let's put what we did into a real calculus equation. So, to help you explain what we did with the potato, I drew out a graph here. F of x represents the change in temperature over the change in time. So, we did it in Fahrenheit degrees, and our goal is to hit 200 degrees, but I drew increments down to help you understand. And the bottom isn't 0, it's actually room temperature. I scaled the graph that way. And the time's in minutes, and it took me a total of an hour to do the whole thing. So that's why it goes up to 60 minutes. When I first opened the oven, or when I first put the potato in, it was 0 degrees. But then I turned the oven on, and it warmed up. But then I opened the whole oven, and that let the heat out. So it slowly started getting cooler and cooler and cooler, and then it went back down to room temperature. But when I put the apple back in again, it warmed up, but then I just turned off the whole oven completely. It sharply went back down to room temperature. Then I realized it wasn't warm enough, so I heated up, and it made it all the way up to 200 degrees. So you're probably wondering, now that we have the temperature, how do we measure the rate at which the temperature is changing? As you can see, when we first put the potato in the oven, it started increasing, but once we opened it up, the temperature was still going up, but it was increasing at a decreasing rate because more and more heat was leaving the oven. But then it got to a point right here, so the change, it was positive, but it was going at a decreasing rate. Once it hit right here, too much heat was escaping, not enough heat was going in, and room temperature went back down to 0. So the rate was decreasing, the temperature was decreasing. Once we're here, we put the potato back into the oven and it started increasing. So we know that because it was increasing, it was going at a steady rate, so the change is at a steady rate. Then it started decreasing, so it was decreasing at a steady rate. Once you make it back to here, you see that I put the potato back in the oven to leave on for a while. So the rate at which it's changing is positive for a long time. So this can be a bit complicated, but what I do to help me understand this is I think of it algebraically. This graph right here represents negative x squared. The derivative of negative x squared is negative 2x, which is right down here, from 0 to 20. Then let's look from 20 to 30. This graph right here is x. The derivative of x is just 1, which is a positive number and it's constant, so it goes from 20 to 30. Now let's look from 30 to 40. It's negative x. The derivative of negative x, negative 1. So it goes under the x-axis, stays constant. Finally, the last part of this. It represents x. The derivative of x, 1. So it's just a steady 1 all the way across.